Hi everyone, my name is Yiwu. I'm an undergraduate from Southern University of Science and Technology. Today I'm going to talk about anti-patterns for Java automated repair tools. So first, let me talk about our motivations. Because of insufficient test cases, automated repair tools can generate plausible patches. Plausible patches are sufficient to pass the given tests, but are incorrect beyond the test suite. And prior study has proposed anti-patterns, a set of forbidden transformations on programs to solve this problem in C program repair. Basically, we use anti-patterns to tell the program repair tools what not to do on the programs. And our study wants to answer this question: do anti-patterns also exist in Java repair tools? And our study basically focused on three categories of anti-patterns. They are anti-append trivial condition, anti-delete control statement, and anti-append early exit. We first studied the prevalence of anti-patterns. We manually analyzed the plausible patches generated by SymFix, Caption, and LS repair, and the results shows that anti-patterns still occurs despite advancement of techniques in Java repair tools. And next, we integrated our anti-patterns in GGenProc2, whose prototype is GenProc in C program repair. And this diagram shows how we check for anti-patterns based on different types of operations. And this diagram shows how the anti-patterns works in the evolutionary algorithm. Besides, we have opened a pull request on GitHub, and the implementation of our anti-patterns has been merged by the developers of GGenProc2 and got positive feedback. So if you are interested, you can click the hyperlink on the poster to see the details, and I will also share the link in the Zoom chat window. And as for the experiment, we evaluate GGenProc2 with anti-patterns using defects4j benchmark. And the results shows that both the average repair time and the number of generated plausible patches are reduced as expected. And we have also observed potentially new anti-patterns, such as controlling the loop condition by irrelevant variables, which can be used to extend the existing anti-pattern set. So in a word, our study has proved the effectiveness of applying anti-patterns in future Java automated repair tools. And that's all. Thank you. Do you have any questions?
I have a question.
Yes.
Thank you for your presentation. Can you clarify, I know you have a short time, can you clarify how patches are generated?
How patches are generated? Basically, there are some like this evolutionary algorithm. Basically, the tools will perform fault localization, and it will specify some some place that may have bugs, and it will initialize the program variant, and do some modifications on the buggy localization. Then with the anti-pattern version, we will check if this newly generated program variant is an anti-pattern. If it is an anti-pattern, we'll discard it. If it is not an anti-pattern, we will compile the program to see if it can be compiled successfully. If it can compile successfully, we will further evaluate it if it can pass all the tests. If it can pass all the tests, then it can be regarded as a correct patch under this given test suite and regarded as a solution for the bug. And also, if you continue to search for more patches, it will the compiled program variant will be added to the variant pool, and the variant pool will be doing some mutation and crossover to generate a new program variant and continue the next iteration.
I understand it. So can you just clarify, did you check the correctness of the patch manually to verify whether the semantics of the program has not changed? So did anyone check about the correctness of the patch, or if the patch was not changing the functionality of the program?
You mean the functionality is not changed? Yeah. We actually we specify our intended functionality of programs by the test suite and also by the anti-patterns, because some test suite are not so strong enough, are not sufficient. So we add the anti-patterns to further limit the behavior of the tools, to not let it delete some important functionality, and thus ensure that the functionality is what we want and get preserved.
Thanks, Yiwu. Thanks for the presentation. And that was